Hi kids, in this video we are going to look at trigonometric identities from class 10. We'll derive the trigonometric identities. We'll look at the basic concept of trigonometry which we have already done in class 9, and we'll solve sums from exercise 18 from M L AGGARWAL, sum number 1 to 11. For rest of the sum you can click on the I button and get the video. Now let's get started. First of all, what is trigonometric identities? An equation of a trigonometric ratio of an angle. That equation is your trigonometric identities. Now we have already done that trigonometry is the study of relationship between the sides of a right angle triangle and one of its acute angle. So the relation between the angle and side, that is trigonometry. We have done it. For example, suppose this is your right angle triangle A B C, and this is the angle in consideration. Suppose this we take as theta, which means we'll express the ratio of two sides of a triangle with respect to this angle. So if this is your angle, remember, this will become your base. This is hypotenuse. We know this. Opposite to 90 degree, you have hypotenuse. And with your angle, you have base and hypotenuse, always. And this is your perpendicular. So the ratio of perpendicular by hypotenuse, which in this case is AB by AC, is known as sine of theta, or the angle, and written as sine theta. Clear? Similarly, the ratio of base to hypotenuse, that is in this case BC by AC, that is known as cosine of the angle, which is cos theta, written as cos theta. This sine theta, cos theta are one single term. Remember that. It is not like cos multiplied by theta. No. Number 3. The ratio of perpendicular by base, in this case AB by BC, is known as tan theta. Now sine theta, cos theta, tan theta, they have a reciprocal also, which means the ratio between hypotenuse and perpendicular, which is AC by AB, is referred as cosec theta. For if you find the ratio of hypotenuse to base, that is sec theta, and the ratio of base by perpendicular is cot theta, which simply means if you multiply sine theta and cosec theta, you'll get 1, because cosec theta is the reciprocal of sine theta, which means I can write sine theta is 1 by cosec theta, and cosec theta is 1 by sine theta. Then I can write cos theta multiplied by sec theta is 1. In this case also, cos theta will be 1 by sec theta, and your sec theta is 1 by cos theta, isn't it? Similarly, you have tan theta multiplied by cot theta. Tan multiplied by cot gives you 1, which means tan theta is equal to 1 by cot theta, and cot theta equals to 1 by tan theta. So this is your reciprocal relation. Am I clear or not? Now look carefully. If you look, if I divide sine by cos, so sine theta I divide by cos theta, what do I get? AB by AC divided by BC by AC, which becomes AB by AC multiplied by AC by BC. So AC cancels out, which means it becomes AB by BC. And if you look carefully, AB by BC is nothing but tan theta, which means I can tell that tan theta is equal to sin theta by cos theta. Am I clear or not? If tan theta is sin theta by cos theta, definitely cot theta, which is the reciprocal of tan theta, will be equal to cos theta by sin theta. Am I clear or not? Okay, so this is your, you can say, quotient relation, that tan theta is sin theta by cos theta and cot theta is cos theta by sin theta. Look at one more relation. Just look over here. Now, suppose I take this angle. Okay, so if this is 90, this is theta, then this will be 90 minus theta. Now I'll find the trigonometric ratio with respect to this angle, angle A, which is 90 minus theta. So when this is your angle of consideration, this becomes your base, isn't it? This is the hypotenuse as it is, and this becomes your perpendicular. Remember that. Because with the angle, you have hypotenuse and base. Opposite to the angle, you have perpendicular. See, in this case, opposite to the angle theta, you have perpendicular. Over here, opposite to 90 minus theta, you have perpendicular, which means, look over here, just look over here. Sine 90 minus theta, if I want to find sine of A. Okay. See, some people have perpendicular by hypotenuse. Perpendicular is BC. Hypotenuse is fixed, AC. And remember, BC by AC was cos theta, which means sine 90 minus theta is equal to cos theta. Okay, which means sine, suppose 20 degree, will be equal to cos 70 degree. How? Because see, this is sine 90 minus 70. Sine 90 minus theta will be what? Cos theta. Similarly, if I find cos 90 minus theta, cos 90 minus theta is curly brown hair, base by hypotenuse. So the base is AB in this case, AB by AC, and AB by AC is nothing but, if you look over here, sin theta, which means cos 90 minus theta will be sin theta. Similarly, tan 90 minus theta, tan was what? Perpendicular by base. So perpendicular by base, BC by AB, BC by AB. So BC by AB, if you look carefully, is cot theta. Am I clear or not? Now look carefully. Similarly, if I want to find cosec 90 minus theta, the cosec theta is hypotenuse, look over here, hypotenuse by perpendicular. Okay, so in this case, the hypotenuse is this AC, and perpendicular is nothing but BC. And look, AC by BC. AC by BC is nothing but sec theta. Am I clear? Which means we have some more results. Similarly, we can say that sec 90 minus theta is cosec theta. We can tell cot 90 minus theta is tan theta. So these are your complementary angle relationship. Okay. Now look at the identities. Now let us derive the trigonometrical identities. Now look over here. I've taken a right angle triangle ABC, where C is an acute angle, which I've taken as theta. Then sin theta is perpendicular by hypotenuse. This is your perpendicular, this is your hypotenuse, and this is your base. Cos theta is base by hypotenuse, tan theta is perpendicular by base, and these three are the reciprocal of these three. Now look over here. If I use Pythagoras theorem over here, so I can say AB square plus BC square is equal to AC square. Perpendicular square plus base square is equal to hypotenuse square. Now what I'll do, I'll divide the entire thing by AC square. So what I'll get? I'll get AB by AC whole square, BC by AC whole square is equal to 1. What I did? Divided by AC square. Now just look over here. AB by AC. AB by AC is nothing but sine. So this becomes sine theta square. BC by AC is nothing but cos. So cos theta whole square is equal to 1. So sine squared theta plus cos squared theta is equal to 1, which can be written as sine squared theta plus cos squared theta is equal to 1. This is your first identity. Okay. Now look at the next one. Again, I'm writing AB square plus BC square is equal to AC square. This time I'll divide by, suppose, AB square. Okay. Then what do I get? AB square by AB square is 1. Then this becomes BC by AB square. And this becomes AC by AB square. This becomes 1. And look carefully. BC by AB is nothing but cot theta. So this becomes cot square theta. And AC by AB is nothing but cosec theta. So this becomes your cosec square theta. Am I clear or not? So this is your second identity, which is 1 plus cot square theta is equal to cosec square theta. One more. Again, AB square plus BC square is equal to AC square. This time I'll divide by BC square. So what do I get? I get, just wait, this is AB by BC whole square plus BC by BC whole square. That will be 1. And this is AC by BC whole square. Now look, AB by BC. AB by BC, where is it? This is tan. So this becomes tan square theta. This is 1. And AC by BC. AC by BC is sec. So this becomes sec square theta. So this is your third identity. Am I clear? So altogether you have 3 identity in class 10. Sine square theta plus cos square theta is equal to 1, which means we can write sine square theta as 1 minus cos square theta, which if you factorize you get 1 minus cos theta, 1 plus cos theta, isn't it? Yeah. You can write cos square theta is 1 minus sine square theta, which we can factorize as 1 minus sine theta, 1 plus sine theta. So these are outcomes of this identity. Similarly over here, see, we can write cosec square theta minus cot square theta is equal to 1. Am I clear? Or we can write cot square theta is equal to cosec square theta minus 1. From this, what do you get? You get sec square theta minus tan square theta is equal to 1. One more we can get. We can get tan square theta is equal to sec square theta minus 1. So these are my 3 identities. Now let us solve sums from exercise 11. Now look at sum number 1. If A is an acute angle and sin A equals to 3 by 5, find the other T ratio. Look over here, we'll draw a triangle, acute angle triangle A, B, C. Okay. If A is an acute angle, so this is definitely an acute angle, and sin A is given as 3 by 5, which means the ratio of perpendicular by hypotenuse is given as 3 by 5. So we can let perpendicular, which means in this case BC, as 3K, and we can let the hypotenuse, which in this case is AC, as 5K. Am I correct or not? Now, by Pythagoras theorem, we'll find the base AB. Look over here. AB square plus BC square is equal to AC square, which means AB square plus BC square is 3k square is 9k square, and AC square is 5k square will be 25k square, which means AB square is 25 minus 9, that's 16k square. So AB will be plus minus 4k. So AB will be positive because it's the side of a triangle. And remember, for acute angle, which in this case was A, the T ratios are always positive. Am I clear? Now, so this is perpendicular is 3k. Just look over here. Hypotenuse is 5k. Okay, and the base is 4k. Now, I'll find the T ratios. Cos A, curly brown hair, base by hypotenuse, which is 4k by 5k, which is 4 by 5. Tan A, tan is what? Perpendicular by base. See, with your angle, you have base and hypotenuse, and opposite is perpendicular. So tan is what? Perpendicular by base, which will be 3 by 4. Now, see, once you got cos A, so sec A will be reciprocal, which is 5 by 4. Tan A is 3 by 4. So cot A is 4 by 3. One more. Sin A is 3 by 5. So cosec A will be 5 by 3. Done. Now look, sum number 3. Express the ratio cos A, tan A and sec A in terms of sin A. A is your acute angle. Remember that. So, the first part, see. Sin square A plus cos square A is equal to 1. A is acute angle, which means cos square A is 1 minus sin square A, which means cos A will be plus minus root of 1 minus sin square A. Now A is acute, which means cos A has to be positive, I told you. So cos A is nothing but root over 1 minus sin square A. Done. Now look over here, tan A. Now tan A, we know, is nothing but sin A by cos A. This relation we have done. Okay, so just substitute the value. Sin A, instead of cos A, can I write 1 minus sin square A? See, I'm expressing tan in terms of cos. So, third one, sec A. Now, sec A, can I write 1 by cos A? And 1 by cos A we already know is root over of 1 minus sin square A. So, I've expressed sec, tan and cos in terms of sine. Okay, now let us look at the next sum. Now look at sum number 5. If 12 cosec theta is 13, find the value of 2 sin theta minus 3 cos theta by 4 sin theta minus 9 cos theta. Very simple. See, now your cosec theta is nothing but 13 by 12, no doubt in that. Draw an acute angle triangle. Just look over here. This is your theta. Suppose A, B, C. Now cosec theta, if you look carefully, is hypotenuse by perpendicular, which means you can take hypotenuse as 13k and perpendicular as 12k. Then find the base. See, BC square plus AB square is AC square, which means BC square plus AB square, 12k whole square is 144k square, is equal to 13k square will be 169k square, which means BC square will be 25k square, which means BC will be plus minus 5k. We'll take the positive because BC is a side. So we got BC as 5k. Now look carefully how I do. 2. Sin theta. Sin theta is perpendicular by hypotenuse, which means 12k by 13k minus 3. Cos theta. Cos theta is base by hypotenuse, which is 5k by 13k. Similarly, 4 into 12k by 13k minus 9 into 5k by 13k. Am I clear? Which becomes, if you solve it, see, 2 12s are 24 by 13 minus 5 3s are 15 by 13. K cancels out. This is 48 by 30 minus 45 by 30. So when you solve, 13 is LCM, 24 minus 15, that's 9 by 30 divided by, that's 3 by 30. So that's 9 by 3, which is 3. Done. And please be careful. I've seen many times cosec theta is 13 by 12. People do write like this, AB equals to 12. No, you can't take AB as 12 unit because this is the ratio. So you have to take 12k. You have to take 13k. You can't take AC as 13 unit because that is a ratio. That's not the exact value. Okay, where k is a common factor. Now look over here, very interesting. Without using T tables, trigonometric tables, evaluate cos square 26 plus cos 64 sin 26 plus tan 36 cot 54. Now look carefully. The complementary angle relationship. Okay. Now if you look carefully, 64 and 26 are complementary angle because they act to give 90. Similarly, 36 and 54, they are complementary angle. They act to give 90. How do you solve it? Just look over here. Cos square 26 plus cos 64. Can I write 90 minus 26? I can write like this. Now, tan 36. Can I write 90 minus 54? See, when we are using the complementary angle relationship, be careful. First, you change one of the angle. See, between these two angles, I've changed this angle. Between these two angles, I've changed this angle. Now look carefully. This is cos square 26 plus cos 90 minus theta is sin theta, isn't it? Multiplied by sin 26. Tan 90 minus theta is cot theta. Am I clear? Now look carefully. This is cos square 26. Sin 26 multiplied by sin 26. This is sin square 26. And this is 1. And we already have an identity. Sin square theta plus cos square theta is 1. So this is 1 plus 1, that is equal to 2. Am I clear? Now let us look at the next sum. Now look at 7 part 1. Similar, see. Find the value of this without using the T table, okay? Trigonometric table. Sin 65 by cos 25 degree plus cos 32 by sin 58 degree minus sin 28 by sec 62 plus cosec square 30. Now, first of all, this is standard angle. We know the value of this. We have already done in class 9. Okay, just look over here. These two are complementary, these two are complementary, and these two are complementary. My first step, change one of the angle. So I'll write sin 90 minus 25. See, out of the two angle, I changed one angle. Similarly, cos, this I can write 90 minus 58. See, if you look at the second angle, you know what to do. 58. So 90 minus 58 is 32. Okay. Sin 58 minus. I'll change one of the angles. See, sin. This is 90 minus 62. Sec 62. Now, cosec square 30. We have already done in class 9. Sin 30 is half. So cosec 30 will be 2. So that's 2 square. Done. Now sin 90 minus theta is cos theta. Similarly, cos 90 minus theta is sin theta. Sin 90 minus theta is cos theta. Sec 62 plus 2 square is 4. Now look, this becomes 1. This becomes 1 minus. Now, cos theta multiplied by sec theta. That is 1 because they are reciprocal. So that's 4 plus 1 is 5. Done. Now look at 8 part 1. See sin 35 cos 55 plus cos 35 sin 55 by cosec square 10 minus tan square 80. Now look, 35 and 55, they are complementary. Over here also 10 and 80 are complementary. Okay, I'll change one of the angle. See what I'll do, sine 35, can I write 90 minus 55? Of course I can write the second one as it is. Cos 35, can I write cos 90 minus 55? And sine 55 as it is, by, look over here, can I write cosec square, this is 90 minus 80 minus tan square 80. Done till now? Now look the changes. Sine 90 minus theta is cos theta, so cos 55 multiplied by cos 55 plus cos 90 minus theta is sine theta, sine 55 multiplied by sine 55. Cosec square 90 minus theta, so cosec 90 minus theta is sec theta, so this will be sec square 80 minus tan square 80. Now if you look carefully, cos 55 multiplied by cos 55, that becomes cos square 55 plus sin 55 multiplied by sin 55, that's sin square 55 by, this is sec square 80 minus tan square 80. Now look carefully, cos square theta plus sin square theta, identity, sin square theta plus cos square theta is 1. Sec square theta minus tan square theta, if you look at this one, 1 plus tan square theta is sec square theta, so if tan goes on that side, sec square theta minus tan square theta is 1. So that's your answer. Done. Now let us look at the next sum. Now look at sum number 9 part 2. Very easy. Find the value of cos square 25 plus cos square 65, which means 25 and 65 clearly they are complementary angle. Okay. Plus cosec theta sec 90 minus theta minus cot theta tan 90 minus theta. Now look, first of all I'll change one of the angle. So this becomes cos square 90 minus 65 plus cos square 65. Now look, this is cosec theta, and sec 90 minus theta is nothing but cosec theta. This is cot theta, and tan 90 minus theta is nothing but cot theta. Done. Now this is cos 90 minus theta is sin theta, so this becomes sin square 65 plus cos square 65. This is cosec square theta minus cot square theta. Now look carefully. Sin square theta plus cos square theta is 1, we know that. And cosec square theta minus cot square theta, if you look over here, identity, yeah. Cosec square theta, 1 plus cot square theta is cosec square theta. So cosec square theta minus cot square theta will be 1, which is 2. Done. Now look at this one. 10 part 1. Cosec square 90 minus theta minus tan square theta. 2 bracket cos square 48 plus cos square 42. These two are complementary. We'll change 1. Okay. Tan square 30. We'll put the direct value because this is standard angle. Sec square 52. Sin square 38. This and this are complementary. We'll change one of the angle. And cosec square 70 minus tan square 20. Again, we'll change one of the angle. Just look over here. Cosec 90 minus theta is sec. So this becomes sec square theta minus tan square theta. Similarly, in the denominator, if you see, this is cos square 48. I can write 90 minus 42 plus cos square 42 as it is 2. Now tan 30. Tan 30. We know the value is 1 by root 3. We have done it in class 9. Okay. So this is 1 by root 3 whole square. This is sec square 52. So I can write sec square 52. I can write 90 minus 38. And this is sin square 38. Just look carefully. In the denominator I have, this you can write cosec square 90 minus 20 minus tan square 20. Now look, sec square theta minus tan square theta is 1 by 2. And this becomes cos 90 minus theta is sin theta. So sin square 42 plus cos square 42. Okay? Minus. This becomes 1 square is 1, root 3 square is 3. So that becomes 2 by 3. And sec 90 minus theta is cosec. So that becomes cosec square 38 sin square 38 by Cosec 90 minus theta is sec. So that becomes sec square 20 minus tan square 20. Now look carefully. This is 1 by 2 because this is 1. Sin square theta plus cos square theta is 1 minus this is cosec theta and sin theta. They are reciprocal to each other. So cosec square theta multiplied by sin square theta will give you 1. So 2 by 3. And sec square theta minus tan square theta is 1. So what do you get? You get half minus 2 by 3. So the LCM is 6. That's 3 minus 4. That's minus 1 by 6. So your answer is minus 1 by 6. Done. Now let us look at the next sum. Now look at 11 part 2. Very simple. Prove that tan theta by tan 90 minus theta plus sin 90 minus theta by cos theta equals to sec square theta. We'll take the left hand side. Just look over here. Tan theta by tan 90 minus theta plus sin 90 minus theta by cos theta. Now we know this is tan theta. Tan 90 minus theta is cot theta plus this is cos theta by cos theta. Now look carefully. Tan theta by cot theta. Now cot. See, tan theta equals to 1 by cot theta. So this we can write as tan theta multiplied by tan theta, isn't it? And this is 1. So this is tan square theta plus 1. And tan square theta plus 1 is nothing but sec square theta. We have the identity. Is it clear? Now look at part 4. Sin 90 minus theta, cos 90 minus theta equals to tan theta by 1 plus tan square theta. We'll first solve the left hand side. See, this is sin 90 minus theta, cos 90 minus theta. So that becomes cos theta multiplied by sin theta. Okay, now we'll solve the RHS and we'll get cos theta multiplied by sin theta. Just look over here. This is tan theta by 1 plus tan square theta. Now, we know the identity. 1 plus tan square theta is nothing but sec square theta. Now, tan theta is nothing but sin theta by cos theta. And sec square theta will be 1 by cos square theta. So, 1 by cos square theta. So, 1 cos cancels out. So, what remains? Sin theta, cos theta, which means your LHS is equal to RHS. Proved. So keep it till here in this video. I have already posted the sums from 12 onwards in the other video. Just click on the I button and you will get it. In the next video, we'll do height and distances for class 10. Till then, take care.